Radical equations, part one, square roots. Okay, so let's go ahead and get started with lecture 22. So this week we're going to be doing radical equations. And I think it's really fitting if I start off with a definition first of what these things are going to be. So let's get started with the definition. Okay, radical equations. What are those? Well, you're about to learn. Radical equations are equations that involve radical expressions. Equations that involve radical expressions. Okay? So that doesn't really tell you much, granted, but these are going to be equations, so you're still going to be solving for x, trying to figure out what x is, and x is going to be a number. Usually they're going to be whole numbers. You're not going to get a lot of fractions for these, but you will be getting numbers for your answers. And at the very end, we're going to put our answers in solution sets, and then we're going to be checking our solutions to see if they're right or not. So that's what a radical equation is. Let me start off with a note. Okay, so a radical expression is going to be an expression that has some kind of root. So typically what's going to happen is you're going to have a root that kind of looks like this, and you're going to have something on the inside, maybe an x plus 3, something like that, and you're going to have an index on the outside, and I'm going to use the number n for that. So this is the nth root of x, and typically when you have a radical expression, it's always going to have 3 components to it. The first component is the radical sign. So this is the radical sign. That's the radical sign. And inside the radical sign, you're going to have what's called your radicand. So we talked about that a few weeks back. But whatever's inside the radical is going to be called the radicand. And the number on the outside, that's always to the left, that is called the index. You probably remember that. This is called the index. And typically our index is going to be a whole number that's greater than or equal to 2. So it could be 2 at the lowest. I've never seen it higher than 3, but eventually we'll get there. We'll look at some different indexes and what they're used for, but typically, when you have a square root, it's going to look like this. If you have a square root, it's going to look like this, right? You can have something like that, or you can have something like this. This is also a square root. Square roots are always going to have an index of 2, okay? But if you have a cube root, that's going to have an index of 3. So a cube root is going to look like this. It's going to be the exact same thing, but it's going to have an index of 3. And then you can talk about fourth roots. Fourth roots would look like this. It looks exactly like a square root, but it's going to have an index of 4, right? So that's the difference between square root, cube roots, and fourth roots. And we'll be looking at cube roots on Wednesday. So that's going to be in the future. But today we're just going to be focusing on square roots. All right, so let me zoom out a little bit and let's do some problems from the problem set. Okay, so the first one I wanted to do was the square root of x is equal to 6. The square root of x is equal to 6. So what I want to do with this is I want to get x by itself. I don't want any square roots in my answer. I don't want any plus 2's or minus 3's or divided by 2's. I'm trying to get x by itself on the left side. And that's what I really want to do. So I asked myself, how do I get rid of a square root symbol? How do I get rid of a square root symbol? Well, I'm going to square both sides. That's what I'm going to do. I'm going to square both sides. And when I square both sides, I'm always going to use parentheses and a square. So I'm essentially taking both sides and I'm raising both sides to the exponent 2. So let's do that. I'm going to put this in parentheses and square it. And I'm going to put this in parentheses and square it. Okay. So now the square root that you see right here and the square on the outside, they're going to cancel each other out. They're going to cancel each other out. So what's going to happen is whatever's on the inside of the square root, I'm just going to take out. So the x is going to come out. And then what's going on the other side? I have 6 squared, and that's going to be 36. So I'm going to put that in my solution set. So this is called a solution set. Okay, so let me zoom in on this and then we'll check our answers. Okay, so all I did was I squared both sides. That's pretty much all I needed to do to solve this one. Now my answer is 36. So what I'm going to do is I'm going to go back to my original equation and I'm going to plug in 36 and see if it works. So the way that's going to look like is I'm just going to write down my original equation, which is square root of x equals 6. And then I'm going to plug in 36 for x and see what happens. So I get square root of 36 is equal to 6. Notice the right side has not changed. And the left side, all I've done is I've replaced x with 36 just to see if it works. And the square root of 36 is positive 6. So I get 6 is equal to 6. That is a true statement. 6 is indeed equal to 6, right? There's no controversy there. So I know that this answer is going to work. My answer is 36. Okay? So I'll leave that up there for a minute so you guys can copy that down, and then we'll move on to some harder questions that are going to involve a little bit more. But typically, the main step is to square both sides. Once you got that radical by itself on the left side, there's nothing around the radical sign. You can definitely square both sides, and whatever's inside the radical sign is going to come out. Okay? So let's look at number 2. Number 2 is going to be the square root of x plus 2 is equal to 3. The square root of x plus 2 is equal to 3. So let's take a look at that. Okay, let me zoom in a little bit. So this is one that I want to solve for x, right? I want to figure out what number x has to be to make this whole thing work. Now, I've got a square root on this side, and I want to get rid of that square root somehow. And the way I'm going to get rid of the square root is doing the opposite of a square root. I'm going to square both sides. So I'm going to take this and put it in parentheses and square it. And then I'm going to take this side and I'm going to square it. So basically what I'm doing is I'm putting both sides in parentheses and I'm squaring it. The reason why I'm using parentheses is sometimes you have a negative number over on this side and you need to make sure that you're getting that negative inside of the parentheses before you do anything. It just makes it a little bit cleaner and easier. Okay? So what happens on the left side? On the left side, the square root symbol and the square on the outside are going to cancel each other out. So whatever's on the inside right here is just going to come down the way it is. So x plus 2 is going to come in. And that's all that happens. Whatever's on the inside of the radical just comes out the way it is. Nothing has changed. Now, over here on the right side, I'm squaring 3, right? So what would 3 squared be? 3 times 3, that's going to give me 9, right? 9. Okay. So now to get x by itself, I've got to get rid of this plus 2. How am I going to get rid of this plus 2? Well, I'm going to subtract 2 on both sides. So when I subtract 2, what answer do I get? The positive 2 and the negative 2 cancel each other out, so I don't have to worry about that. But on the other side, I have 9 minus 2, and that's going to give me 7. Good. So my solution set, when I write my solution set, I just put the 7 in there, and I'm done. Okay. So moving it over a little bit, we're going to check our answer on the right side. So let's do that. So my original equation was square root of x plus 2 is equal to 3. So I write down what they give me for the question before I did anything to it, right? And then what I'm going to do is I'm going to take the answer that I got, which is this 7 right here, and I'm just going to replace x with 7. So when I replace x with 7, what happens? I get 7 plus 2 on the inside. And the right side stays the same because there was no x that I needed to put in over here. All right. Now 7 plus 2, that's going to give me 9. So I get square root of 9 is equal to 3. Again, nothing has changed on the right side, but something has changed on the left side. And then the square root of 9 is 3. So I get that true statement. 3 is equal to 3. So that's how I know this 7 is going to work out. Okay. Let me zoom on out. And let's get started on 3. Okay. Number 3 is going to be a tall radical. So it's going to take up 2 spaces on your paper. The square root of x divided by 3 is equal to 4. Square root of x over 3 is equal to 4. Okay? So here I have a tall radical, and that's because I have a fraction on the inside. But that doesn't really change anything. You still solve it like any other radical equation. You would start off by squaring both sides because I want to get rid of that square root right there. So I'm going to write this in parentheses. Square root of x plus 3, square that. And then on the other side, I'm going to have 4 squared. And I always make sure that I put everything in parentheses before I square it. Okay? That is super important. Don't forget to do that. Okay. So whatever's inside the radical is just going to come out because the square root and the square on the outside actually cancel each other out. So whatever's on the inside right here just comes out. So x divided by 3 is going to come out. And then what's going on the other side? Well, 4 squared is 16, right? So this is going to be equal to 16 on the other side because I did 4 times 4. Okay? Now, to get x by itself, I need to get rid of that 3 that's in the denominator. So how do I get rid of something if I'm dividing? Well, I do the opposite of dividing, right? The opposite of dividing is multiplying. So I'm going to multiply both sides by 3. So I'm just going to stick a 3 right here and see what happens. So I'm multiplying both sides by 3. On the left side, the 3's are going to cancel out because one's in the numerator, the other one's in the denominator. The x is going to come down, and then on the other side, I'm going to have 48. So I know what my answer is going to be now, 48. I put that in my solution set, and then I want to check it. Okay, so let's see if 48 actually works. What I'm going to do is I'm going to copy down my original first before I put anything in. Sometimes I forget to do that, but you're just copying down your original equation. Nothing else is happening at this point. And then what I'm going to do is I'm going to replace x with a 48. So let's see what happens when we do that. We're going to have 48 divided by 3. Take the square root of whatever that is, and it should be equal to 4. If not, that means we messed up somewhere, right? Okay, so on the inside, 48 divided by 3 is 16. So I really just have the square root of 16 on this side. And I still have 4 on the other side. This hasn't changed yet. So then what's the square root of 16? That's going to be 4. Not negative 4. We'll get to that later. It's going to be a positive 4. All right? Okay. So I get that true statement at the end. That means my answer works. Good. All right. Let's look at number 4. And then we'll do 5, 6, and 7. And that should be it. Okay, number 4. I got the square root of x minus 1, but then I have a plus 3 on the outside. So the plus 3 that's on the outside is not under the radical. It's completely separate. And the whole thing is set equal to 6. Okay? So I've got the square root of x minus 1. And I want to make sure that the plus 3 is not under the radical, right? So I'm going to write it way over here just to show you that it's not part of the radical expression, right? The only thing that's under the square root symbol is x minus 1. So the first thing I have to do is I have to do what? Well, before I square both sides, which you think is what I'm going to do, I've got this plus 3 in the way, right? That's going to make it very difficult to square both sides if I still have this plus 3 right here. So I've got to get rid of it. I'm going to subtract 3 from both sides. That's what I'm going to do first. That way, the only thing I have on the left side at this point is going to be the square root of x minus 1. And it's going to be equal to 6 minus 3, that's 3. Okay, so now I can square both sides because I've got the radical by itself, like I want it. If I had started off by squaring both sides, then I would actually end up with a FOIL question where I'm taking this plus this, and then I'm squaring it, which means I would have to square this, then I would have to square the 3, and then I'd have to multiply them together, and it gets complicated, right? So I'm not going to do that, but I'm sure it would work if you tried it. It would just take a whole lot more steps. That's why I'm getting rid of the 3 first before I do anything. Okay? So now let's square both sides. I'm going to square the square root over here. and I'm going to square the 3 over here. So I get something that looks like this. Now, whatever's on the inside of the radical, just bring it out the way it is. Nothing has changed inside here. So the x minus 1 comes out, and over here, I'm actually going to have a 9, because 3 squared is 3 times 3, right? Okay, so now I've got that x minus 1. How do I get rid of a minus 1 to get the x by itself? I've got to add 1 to both sides, right? So if I add 1, what's my answer going to be? I get x is equal to 10. 9 plus 1. So that's going to be in my solution set. All right, let's check it. So over here, I'm going to write down my original equation. Not changing anything. Okay, so I write down my original equation, and wherever I see an x, I'm going to put in 10, because I'm just checking it to see if it works. So I get the square root of 10 minus 1 plus 3 is equal to 6, right? That's all that's changed. The x has turned into 10, because 10 and x are the same thing, right? Okay, so 10 minus 1, that's going to give me 9. So I actually have a 9 under the radical. Okay, so the square root of 9 is going to give me what? 3. So I get 3 plus 3 equals 6. And then what's 3 plus 3 on this side? That's going to be 6. So this is actually going to work out. Okay. Okay, 3 more to go. Let me leave that up there for a minute, and I'll write down numbers 5 over here. Okay, number 5. Okay, number 5 is 2 times the square root of x is equal to 10. 2 times square root of x is equal to 10. So basically, I'm doubling this radical. Now, it's very important that you understand that we're multiplying by 2, right? This is not an index. If this was actually an index, it would look like this. This is a square root, right? All square roots have an index of 2, right? This is not the same thing as this. Not the same thing. Because this 2 is multiplying. But this 2 up here, this 2 serves as an index, right? That's the difference between this and this, okay? So what I actually want to do first is get rid of the 2 out in front. How are we going to do that? We're going to divide both sides by 2. So I'm going to divide both sides by 2 and see what happens. And what happens is the 2's are going to cancel out. And I'm just going to have square root of x is equal to 5. Square root of x is equal to 5. Okay. So that's how I get rid of a 2 if it's multiplying. I divide both sides by 2. So now I square both sides. I get the square root of x. I square that. And I put the 5 in parentheses and I square that too. Okay. The x is going to come out. And then on the other side, I'm going to get 25. Because that's what 5 squared is. And that's it. I've got x by itself. I can write my solution set as 25. Okay, so now I know what my answer is, and now I'm ready to check it. So I go over here, and I have 2 times the square root of x is equal to 10. I'm just writing out what they gave me in the first place. And then I'm going to replace the x with my answer, my 25 right here, right? So I get 2 times the square root of 25 should give me 10. So I replace the x with a 25. And now I take the square root of 25. Then I'm going to multiply it by 2. So I get 2 times 5 is equal to 10. Is that true? Yes. So this answer is going to work out. Okay. That is number 5. I'll leave that up there for about a minute. All right. Now, let's look at something that might trip you up. Let's look at number 6. Number 6 is going to be the square root of x minus 2 plus 3 on the outside is equal to, let's say, 1. So this is number 6. We're going to do this next. So the square root of x minus 2 plus 3 on the outside is equal to 1. And I'm putting that plus 3 on the outside just to make sure that that plus 3 does not end up inside the radical sign, because these two are totally different things. Okay? Now, the first thing I want to do is, you think you want to square both sides, but you got to get rid of that plus 3 first. So how do I get rid of a plus 3? I'm going to subtract 3 from both sides, right? So I'm going to subtract 3 from both sides and see what I get. Now over on the left side, the 3 and the minus 3 are going to cancel each other out. So I don't need to worry about those. So the only thing I'm going to have on the left side is the square root of x minus 2. And what happens on the right side, 1 minus 3 is going to give me negative 2. So I get a negative number. Good. All right. So now I've got the square root of x minus 2 by itself. I can get rid of the square root by squaring both sides, right? So I think, what's the opposite of a square root? It would be squaring both sides, right? So I'm going to put this in parentheses, and I'm going to square it on the outside, like that. And then this negative 2, I put that in parentheses, and I'm going to square that on the outside as well. Okay? So what happens is the square root and the square are going to cancel each other out. Whatever's on the inside of the radical, I bring down. So I've got x minus 2 is equal to what? Okay, what is negative 2 squared? That would be negative 2 times negative 2, right? Well, a negative times a negative is going to give me a positive, right? I get 4. You should get a positive 4 on this side. Okay? All right. So I've got x minus 2 is equal to 4 now. The last thing I have to do is I've got to get x by itself. I've got to get x by itself, right? So how am I going to get rid of this negative 2? I'm going to add 2 to both sides. So when I add 2 to both sides, what's my answer going to be? It's going to be 6. So I put 6 in my solution set. Okay, let's check it. All right, so just like always, I write down my original equation. Don't change anything to it yet. We'll get to that. Just writing down what they gave me in the first place. Okay, so this is my original equation. What I'm going to do now is I'm going to let x be 6 and see what happens. So I'm going to get the square root of 6 minus 2 plus 3 on the outside is equal to 1. Pretty simple, right? All I'm doing is I'm replacing x with 6. Okay? So what's 6 minus 2? That's going to be 4. So I get the square root of 4 plus 3 is equal to 1. We're almost done. I just need to take the square root of 4 and add 3 to it. Well, what's the square root of 4 going to be? That's going to be 2, right? Positive 2 plus 3 is equal to 1. And I'm kind of getting nervous now because 2 plus 3 is not equal to 1, is it? No, it's equal to 5. So I get 5 is equal to 1. That is false. So it turns out this answer 6 over here is not going to work. So I've got to take it out of the solution set. And if I take it out of the solution set, there's not going to be anything left inside the set, right? So this means no solution. No solution. Again, if you check your answer and you get something crazy, like 5 is equal to 1, that means that the solution that you got in the first place does not work. And you need to go back and figure out how you messed up. Now, luckily for me, I know exactly where I messed up. It's right here. Right here. Notice this. I've got the square root of x minus 2 is equal to a negative number. Is that possible? Can I take the square root of any number and get a negative? Has that ever happened? No. That's why this is messed up. It's this step right here. I've got the square root of whatever is equal to negative 2, and that simply does not work. This would have to be a positive 2, right? It would either have to be a positive number or 0. You can't take the square root of anything and get a negative number. That's why this is no solution. And whenever you see a negative number on the other side of a radical, you will know now that that is no solution. Okay? And in your second classwork, in your classwork part 2, there will be a no solution for one of them. For one question, there will be no solution. So it won't be the homework for today, but the homework for Wednesday, one of them is going to be no solution. And that's because you're taking the square root of any number. You're not going to get a negative number out of that. It's impossible. So that's why this is no solution. It's because you got a negative number on the other side. Okay? So that's the tricky one. That's why you always want to check your answer when it comes to equations. You really don't know what you don't know until you actually check it and you see if it works or not. If you get a true statement, fine, it works. But if you get a false statement like that, it's not going to work. Okay? Let's do the last one. Number 7. And this one is kind of interesting because now we're getting into cube roots. We're getting into cube roots now. And this will be the last one we do today. So this time I've got the cube root of x is equal to 2. I'm not doing square roots anymore. Now, when I do cube roots, what I want to do to get x by itself and get rid of this radical, I've got to cube both sides. I need to cube both sides. And that's going to involve putting everything in parentheses like this, and then cubing both sides. So let's take a look at how this would work. I would put this whole radical in parentheses, cube it, then cube this, right? Whatever's on the inside of the radical is going to come out. So the x comes down, and then over here, I've got 2 cubed. Well, 2 cubed is going to be equal to 2 times 2 times 2, right? 2 times 2 times 2. And that's going to give me 8. That's going to give me 8 for my answer. So my solution set is going to be 8. Okay? So now let's check our work like we usually do. I write down my original equation, and wherever I see an x, I'm going to put in the answer that I got, this 8 right here. And what's the cube root of 8? That's going to be positive 2. So I get 2 equals 2. So that works. Good. Okay, so that's how you solve a cube root equation. You're not squaring both sides because the index is 3 now. You actually have to cube both sides.